Good morning, everyone. Welcome to another episode of Xa Talk Show. Today we're going to talk about Wolfram Language Mathematica. Lots of interesting things. And so it's mostly going to be Wolfram Language. Post your questions in the chat box. And I'm going to do some demo of Wolfram Language Mathematica. And I'm going to give you a basic tutorial for programmers how to program Mathematica. Mathematica is huge, Now it's got 6,000 functions built in. You don't need to load any libraries. 6,000 artificial intelligence functions built in. So I'm going to first of all I'm going to tell you how to get Wolfram language for free, and there are 3 videos I did before on Wolfram language on the nature of the Wolfram language, and mostly my audience, you guys are programmers. That's what that's my topic is going to about. I'm talking about Wolfram language for programmers. So you can ask me questions in comparison to Python, Lisp, things like that. And so I did 3 videos before. Check them out in the past month. It's on my YouTube. Just search for my name and Mathematica or Wolfram language. So I'm going to show you a very interesting thing about this contour plot. Okay, this is a problem in computational geometry, and it's very interesting because you can try to implement this in your favorite language, in Python, Python with AI or whatever, in Golang, in Scheme Lisp, you can try, and you of course you need a graphics library or something to do this, but this is a very hard problem, okay, and it's very easy to understand. I'm going to explain and show you. So then I'm going to basic tutorial on Wolfram language, and I'm also going to show you Wolfram language is tremendous, huge. Wolfram language doc, okay, it's 6,000 functions. I'm going to show you how to learn it. Like how is the tutorial, their documentation structured. One of the interesting questions is, as a technical writer, documentation writer, if you are a programmer, you read about documentation in Python language, in Golang, in Lisp, each one has their different documentation writing style and organization style, and yeah, they have Perl, Python, Ruby. They all have different styles, and they Java, for example, with the Java doc. So one of the interesting problem is about organization and how do you specify a function. For example, if you have a function, it takes several arguments, and some of the arguments are optional. How do you write it? How do you present that? And different programming languages, they all have different styles, and one of the interesting problem for Wolfram language is that you have 6,000 functions built in. So, how do you categorize it? For example, in Java, if you are a programmer for Java or Python or Golang, each one have different style. How do you find the function you want? So, for example, in Java, they categorize everything into a object tree, kind of. So you have the left panel of interfaces and objects. And for Python, it's a mess. For PHP, you just search for the function name, or what do you try to do? Array, take elements of array for PHP. Usually, you'll find it right away. And for Emacs Lisp, for example, the documentation organization is hell. Basically, they want you to read from the beginning page to the end. Very hard to find exactly what you need. So different styles, So one of the problem in writing a documentation for a programming language is how do you organize organize your functions. It's fairly complex because sometimes you have built-in variables. Sometimes you have functions. Sometimes a function belongs to in another library, so you have default libraries come with the language, such as Python, so-called battery included. So if Python is battery included, then Wolfram language is the whole earth included. So 6,000 functions. How do you you know write a documentation for them so that things are easy to find? I'm gonna show you how to go about, because nobody, yeah, even including Stephen Wolfram, the guy who created language, made half of the, a lot of the functions he may not remember and don't use, because it has become very huge. And so how do you go about learning the Wolfram language? And I'm also going to tell you which there are quite a few books on Wolfram language. There are tutorials. I'm going to tell you which one I recommend. And so then I'm going to give you a basic introduction to Wolfram language. I'm going to go fast today, okay, to focus on this. And I'm going to show you type settings in Mathematica, some syntactical features, how Wolfram language shares the nature of Lisp or the Lisp characteristics. Okay, and that's about it. And also you can Wolfram notebook. What is a notebook? How it is. In fact, you can think of notebook is a magnet. It's like a OGMOD. My audience like OGMOD. Wolfram language is one magnitude beyond that. It's just like OGMOD. But it's one magnitude beyond. You can evaluate code. You can create headers and footers. You have images and so on, and including animations and synthesizer. Yes. You have functions that create sounds. You give a wave function for a sound. You play it. So 6,000 functions. One way to characterize Wolfram language is saying it's a AI. It's a AI programming language. Okay, it's a AI building AI programming language. You can think of it as that. In fact, it has a natural language recognition. So instead of typing code, I never actually used this function, but let's try it. Okay, plot sine. Okay, let's magnify. Natural language recognition. Okay, so that's what suppose this will work. Let's try it. Okay, actually, yes. So how do you actually? Okay, you just click on that. Indeed, fantastic. What? Wait, where is the output? This is this is okay. Wait. So actually, from what I know, sine. So cut that. You don't want to evaluate. Okay, paste. Let's try that. What's going on? Okay, maybe I need to restart Mathematica. Let's try again. Okay, evaluation, quit kernel, quit local kernel. Yes, so that maybe I did something that screwed up things. Mathematica. So let's do 1 plus 3 plus 2. Okay. Okay, the kernel began. Let's magnify a bit. Okay, so now I want to use natural language recognition. Okay, plot sine, plot cosine. Okay, cosine. Let's see what happens. Okay, so I never used this before. So it's telling you, it's interpreting the meaning of plot sine, and it gives this result. And this result is supposed to be the syntax for Wolfram language to plot cosine. So let me just copy that. So you just click on that. It becomes that. Evaluate. Wait, what happened to my Mathematica? This is okay. That's embarrassing. So let's try it manually. Plot sine x, then x from -7 to 7. Enter. Okay, I think that's a bug. Jesus. natural language processing. That doesn't work for some reason. I have to figure it out. Okay, I have to show all results. Input interpretation. Okay, and okay, it actually plots it, but then wait, can I actually adjust this? I should be able to, but something is wrong. I'm not sure. I never used this before. But anyway, so let's go back. So if you have questions, post it. Okay, I'd love to see you. Hi, Victor. Okay. So how do you get it for free? First of all, so you go to my website. Very easy. Okay. So let me show you. You just go to my website, xali.info, and you go to programming. You go to programming tutorials, you go to Wolfram Language, then here's one of the video I did on Wolfram Language, two of them. Actually there's three by now. I'm beginning to update this page. So then here is how do you get Wolfram Language for free. So you can either buy a Raspberry Pi, it's included, the full version, okay? But you can only run it on Raspberry Pi. Or you can download, for free the Wolfram engine, the Wolfram script. It's free, actually. In fact, I recommend you just buy it, okay? So copy that back to Emacs. Let me write down how to get Wolfram Language for free. Yeah, okay. So I did 3 videos before. Let's go over the topic and let me show you, okay? So now let's talk about this very interesting computational geometry problem I just discovered today. I programmed Wolfram Language for like 10 years, mostly in the 1990s. Like I read the 1,000-page documentation. In fact, that is still good. Okay, they don't sell it anymore. But you go to the last printed book for Wolfram Language is called the Mathematica book. Okay, you go to Amazon. You type the Mathematica book. Okay, this one. Okay, so the Mathematica book, the 5th version, I believe that's the last one. This is, and this is version 4. So the Mathematica book. Okay, so when you click on that, this is so 18 used from $22. This is like 1,200 pages. This thick. Okay, it's very heavy. So in the 1990s, I read this book 3 times from cover to cover, from the first word, preface, whatever, to the last word 3 times in different years. So I'm a master. I'm a master of Mathematica, but I haven't been coding Mathematica for 15 years. The nature of the language doesn't change. Okay, Mathematica. So do they have a picture? If you search online, you'll find a picture of this book, this thick. So this book, actually, I still recommend it, especially it's cheap. I still recommend it because if you read this book, you'll learn the fundamentals, the core of Mathematica. Since let's say year 2000. I mean before year 2000. After year 2000, they just added tons of new functions. Each function is like a little artificial intelligence program. You'll see. Okay, let me show you. Let me start to talk about that. Why is Mathematica? I call it artificial intelligence language. Built in. So let me show you this very interesting problem. Wolfram Language notes. Okay, these are the kind of my to-do things. I'm writing them down. So there is this list contour plot 3D. Okay, so let's go to Wolfram Language. So list contour plot 3D. Let me show you. List contour plot 3D. Okay, let's go to the documentation. But so you are looking at the documentation of the Wolfram Language, and by the way, this is exactly the same thing. If you go to the Wolfram Language documentation web page, it's exactly the same thing. I just have a local version. So I'm going to tell you how do you which part to read, because there are too many. You can read it for a few years. But first of all, let me show you this very interesting thing. So there's a built-in function that's list contour plot 3D. So what does it do? So you give it an array, three-dimensional array, basically a nested, just like a matrix, okay, three-dimensional matrix. Then it plots it as a contour. So what that means is that let me show you. Okay, so maybe I can show you. Okay, it'll take some time to show these, but anyway, let's evaluate these. Okay, let me explain what these do. So basically you have a. Let me first explain. Okay, so basically, evaluate. So basically, and then you can rotate it. So this is like an implicit plot, by the way, but it's a three-dimensional implicit plot. To plot in implicit functions is hard. Okay, it's a computational geometry problem. Good morning, Ripper. Good morning, Dizzy. I learned math in English when I was like studying when I was 20 years old. Have you written an article about math learning roadmap? What to learn first and next? Yeah, but can you run a repo for Wolfram in GNU Emacs? Yes, you can. There are several packages to do that. There was a package even in the in year 2000. Okay, but over the years, there's a lot change. In the 1990s, Wolfram Language actually supports Emacs key binding. There's an option, but they dropped that around 2005 because the Emacs people they dwindled and dwindled and dwindled, and in the 1990s it's fairly popular for lots of editors to support Emacs key binding, but not today. They begin to remove it around 2005 or so. Because the Emacs group they just shrinked. And by the way, Stefan Wolfram is also an Emacs user. He was. I'm not sure today, but he was in the 1990s. So they are still. I think they are still Emacs packages that connects to the Wolfram language, so you can code inside Emacs list. But I'm not sure how robust are they. I don't think none of them are very good. So anyway, so the reason you can do that is because, like I talked about last time, Wolfram language, it comes in two parts: the kernel or server. It's commonly known as server, and the front end. Front end is what you see, the notebook. So front end, whenever you evaluate something, it talks to the server. It sends the information to the server. Server replies then by a Wolfram language protocol that was used to known as MathLink, but I think they changed the name. It was known as MathLink. Okay, that's a protocol for Wolfram language communicating to the front end and the server. The kernel is called kernel. So you can write, you can any IDE, in Emacs, in Vim, even I suppose if Vim script can do that. I mean, in basically in VS Code, you can write you can write an interface to Wolfram language, using the MathLink protocol or whatever it's called today. So anyway, so let me explain this thing. Okay, so this thing is let me just explain. Okay, so this function. What's interesting about this function? This function involves AI, okay, or rather, it involves a lot computational geometry. Okay, let me put it this way: you could implement this function. It will take you a year. Okay, it will take you a year just to implement this one function to plot this thing. How is it? So it's a lot of different computational geometry knowledge involved. You need to do it efficiently. So what does this do is that you have a so you are given a three-dimensional matrix. Okay, let me show you the matrix. Okay, let's just show it. Okay, so this actually generates a matrix. Let me show you. Okay, so here's the expression x squared y squared minus z squared, and plus a random number. So why do they put that? Because I guess they put that, they add a little random numbers to jiggle them a little bit. So it actually shows the power of this function. The function actually will find the nearby points and connect them into a surface. But anyway, so this expression is just basically x plus x squared y squared minus z squared. And that, if you set that equals to 0, what you get is this cone, okay? Very sharp, clear double cone. Actually, we can plot that. Yeah, plot 3D, I think. It's been a while I used Mathematica, so I have to, yeah, I suppose these no, not plot 3D, because this is kind of a implicit, yeah. So you see, anyway, so here's the expression, okay? That if you set that equals to a constant, so you get a equation of 3 variables, x, y, z. And to find the solution, solution set, if you plot it, it's going to be a double cone. So they added a little bit random number. But anyway, so this expression, if you want to generate a matrix, you can use this table function. So here x goes from -2 to 2 in steps of 0.2, and similarly for y and z. Okay, so let's evaluate it. So you got huge number of output. That's why you see these kind of condensed output. So let me do a little, let's say in step of 0.5, so we don't get that huge output, so that you can actually see the structure. So here is the matrix, three-dimensional matrix. Basically it's just a nested list. Okay, so for example, this is the one row of the list, 3D list, so it's nested twice. So you got a bunch of points, not a bunch of values, not points. So 3D matrix, you got a bunch of values. So you want interpreted it. Each value has an index. For example, first element is 1, second element is 2. Now, so for example, this one, the index for this number is 111, because that's in the first because that's the first row, and inside this row it's the first another dimensional row, and inside this row it's the first item. So the index for this number is 111, the index for this number is 112, and so on. And for this one is 121. Okay, so each element in the 3D array has a index. So an index is 3 numbers. So the 3 numbers, you can consider them as coordinate in 3D space, x, y, z. So essentially what you get is you got a space, 3D space, that each grid point is a value. Okay, so all these value correspond to fill out the space in a cube. Now, in order to, so that's a 3D matrix, okay, 3D array, whatever you call it in different languages. Now, in order to, so what this function does, list contour plot, is that, so it takes a 3D matrix, like what we had, a 3D matrix, a bunch of numbers that fills a space. You want to find out, the first job is to find all the numbers that have the same value, okay? You want to find all the numbers that's the same value or approximately the same. Now, this thing alone, you can write this in Python, not too difficult, in an hour. But to do this efficiently, that's not a trivial problem, because essentially you have to compare each number to every other number and repeat. So it's exponential if you do it in a brute force way. So first problem is that you have to find, given a potentially tens of thousands of numbers, you have to find all, in other words, equivalent class. You have to categorize the numbers so that you have to find all the numbers that are the same. Now that's the first step. not easy to implement efficiently. The second step is that you want to, if two numbers, okay, so if two numbers in this matrix have the same value, for example, can we find it? No, it will be hard to, for example, this number is 5, maybe there's another number that's also 5.29 something. If two numbers are the same, you want to see if they are adjacent. You want to see if they are adjacent to each other. If they are, then they kind of form a connection. You want to see if they are connected. If they are not adjacent, they are not. Now, how do you tell if they are adjacent? Basically you tell by the matrix index, because remember, these numbers correspond to like grid points in the in this cube. So you want to find which numbers are adjacent. The same numbers are adjacent, and that's again a very computational intensive problem. That's also that in computational geometry you study this. So that's the second thing. Then after that, you got a bunch of numbers that should represent this cone, 3D coordinates. Each number is not actually a coordinate. Each number is just a number, but their index forms the coordinate. So after that, you got a bunch of basically dots, points. You want to draw a surface, and how do you do that? That's another computational geometry problem. You got a bunch of numbers, they form a surface. You want to mesh. You want to create a mesh out of it. So let's see, for example, let's do a one with mesh. Okay, so you can actually see the mesh. Okay, they do the mesh in a different way, but typically it's triangulation. Okay, so for every 3 points you want to connect them, and that's not easy. So that is what this function does. So that's what I'm talking about. That's explains that. Okay, so how long have I been talking? 51 minutes. Shit, I gotta go in 20 minutes. I didn't even begin to talk about lots of the things I want to talk about. Okay, so okay, let me continue with this then. Now, so you got this list contour plot. Okay, now there's another one that's actually more complex. One step more difficult. Let's go to home. Let's go to visualization and graphics. Okay, data visualization. Then you have tens of functions that does plot. So I want to show you. So I just showed you this list contour plot 3D. Then let me show you another one. List contour. Okay. Now the next function, this one. Okay, list contour plot. List slice contour plot 3D. So basically, you have a contour. Basically a plot of a implicit equation with 3 variables. Now this is more advanced. This now you want to slice it with a plane. Then you want to draw the contours on the plane. So what does that mean? Well, it means you have suppose you have one surface in 3D space. Then you have another plane that intersect the surface. So basically what you want to do is you want to find the points of intersections and draw that intersection as a curve on the plane. So that's what this function is about. List slice contour plot 3D. Okay, but not just that. The intersection, the plane can actually be any surface. So basically, you have a surface, then you have another surface. They intersect. Then you can use this function to plot it, and all the intersections will become curves on this on this surface. So that so that's my that's very interesting. So this is one of the 6,000 functions in Mathematica. That's why I say that Mathematica is kind of gather, how the way Stefan Wolfram put it would be the knowledge base, knowledge base meets computation, something like that. Basically, it embodies, you know, the Wolfram language embodies all knowledge, essentially all, okay, well, or in a practical sense, embodies all computational knowledge. That is, whatever, all the algorithms we know, if it's useful, it's already in Wolfram language. For example, you might heard of coding problems, interview coding problems, like for example, Levinian distance. That computes the distances between strings, something like that. Okay, so you have several articles on that. I spelled it wrong. Hey, wait. There's a Wikipedia article on that. Okay, there it is. Okay, Levenshtein distance. Levenshtein distance is a way to calculate how different two words are from one another. Okay, like sometimes this is posted as a interview problem. You have to be smart to implement that. But so this is one of the algorithm about strings, and I believe it is in Wolfram language. Okay, so let's try it. No, Leven. Okay, I don't see it. Okay, let me do this. Okay. Oops. What did I do? Just type. Multiply. Wait, where is multiply sign? Okay, that's wrong. Okay, I don't see that. Levi-Civita tensor, whatever that is. Levi-Civita tensor gives the d-dimensional Levi-Civita totally anti-symmetric tensor. Tensor is basically like a multi-dimensional matrix. Levy distribution represents a Levy distribution. I don't know what that is. So, but anyway, this shows some of the examples of, let's look up Wikipedia. What the hell is Levy distribution? Now, let's first of all see the documentation. Okay, Levy distribution. Some distribution in statistics. Okay, so now I'm pretty sure there is a Wikipedia article on that, but it may use a different name. Sometimes the choice of naming is different. Oh, there it is. File Levy distribution PNG. Now where is this used? Okay, interesting. There's actually no English version of this distribution. There is French, Polish, something UK. Wait, what is Russian? There's no English article on this. But anyway, so that's why I say Wolfram language is embodiment. Is kind of a AI language construction. Okay, let's go on to the next topic. Okay, let's see what next thing I want to talk about. I need to go in like 20 minutes. Okay, how to learn Wolfram language? Show Stefan Wolfram's tutorial. Yeah. Okay. So Okay, so back to Wolfram language. How 6,000 functions. Where do you begin? Okay, first of all, you can use Wolfram language as a fantastic graphics calculator. Okay, just they categorize their functions into fields. For example, if you are interested in sound and video sound generation, let's say sound. Okay, play display sound notes. Okay, let's go sound. Okay, you can. Okay, so sound note C, that plays the note C and G. Okay, I don't know if you can hear it. Can you hear it? Let's see. Let me play it again. Yeah, you can hear it. And then you can also give a function, a wave function. So here is a sine wave, which is a pure function. They actually they play two different waves. So let's play it. Let's evaluate. So this is kind of, so you can imagine this as a fundamentals of a synthesizer. So you can actually start to write a program to build your own frequency modulation synthesizer or addictive synthesizer. You can do that. In fact, there's a blog, someone actually did it. So if you have Wolfram language, you can create, you can write your own synthesizers because, these functions are built in. So that's why I say, have you ever seen a language that does that? No. Not Haskell, not the fancy Haskell, not Erlang, well, of course, they have different purposes. Rust, Julia, but Wolfram language is kind of the giant engine that includes everything. You just sit here like in my power station, and you can compute almost anything that's practically in a language. So sound function. So what else I want to say? Okay, so I was saying, so first of all, you can just play with Wolfram language. You look at the different categories, visualization. Like I just did. I'm trying to get a because I haven't been coding Wolfram language for like 15 years seriously. So I wanted to get an overview what is new. So I started to look in detail the whole documentation. And visualization is one of my primary interests. So I started to look. So one way easily, you can just explore, just different things, sound, videos, or if you are interested in, for example, here is image manipulation. You can actually build a Photoshop with code. This is new. I haven't used any of these, but image manipulation, higher mathematical computation. Now this is kind of the traditional computer algebra system. You can solve linear algebra, tensor algebra, polynomial algebra, whatever degree, 10th degree polynomial, real complex analysis, integral, and so on. Discrete calculus, iterated maps and fractals, neural networks, there it is, AI, probability theory, and so on. So that's a category of math, which is the classic purpose of Mathematica, Wolfram language. So string and text, here is a category you programmers or system admin are interested, all about manipulating strings. And actually, I discovered the Wolfram language is regular expression is I don't want to say it now because I haven't actually looked into it in detail, but I got the impression it's far more powerful than regular expression, Perl or whatever. Because anyway, I'm not going to get into because I haven't, I'm not too sure. I only looked at it, I got, for a minute. So graphs and networks, if you are into graph theory, here is graph theory stuff. Let's see, graph plot. So given any graph, you can plot it, and it will automatically figure out how to arrange the points so that it came out something easy to read. So you have tree plot. Uh, you know, I know there are packages doing that, and doing this is not again it's not trivial. Okay, it's another layout of graphs is computational geometry problem. You are given a graph. Okay, you can actually magnify it. So this is a graph. So how do you represent a graph? Basically, you give a list of labels, then you give a list of edges. Each basically array. Okay, each element of the array is two labels that represent an edge of a graph. So you just a bunch of data. A bunch of edges. So that represents which points are which label or whatever symbol are connected to which. Like each label can be A, B, C, D, E, F, G. Each one of these node is A, B, C, D, E, F, G. You can have thousands of them. Then you have a list of data that says which are connected to which. So it's just a bunch of data. But you want to show it. So how does Mathematica know? In the case of this particular graph, it's symmetric. It has a bilateral symmetry. It's a non-trivial problem given the arbitrary graph to format it for visual representation in the best way. So for this graph, there are so many different visualizations. You can plot it like a tree, or in this case a circular. So Mathematica will actually automatically figure it out. That's what I mean by Mathematica is kind of has all the AI built in. So if you for example, if you are a computer scientist, a PhD, suppose you are a PhD in computer science, there are so many subfields, computational geometry, graph theory, so you have you have lots of algorithms, finding the path of a graph and so on, and also representation of a graph. And you can go to Wikipedia, then you'll see 100 articles about graph theory and algorithms. So the point about Mathematica is that if there's an algorithm known, it's built in. Okay, so how does Mathematica know to plot this way? Because it has algorithms. It automatically choose using AI to choose the representation for you. So that's what I mean. So first of all, in order to learn Mathematica, the 6,000 functions, you can just explore all these. Okay, then let me tell you two things to learn it systematically. Now, as a programmer, okay, one of the way. Okay, when you look at this page, the thing you really want to understand as a programmer is the first part, core language and structure. Okay, again, there's so many. So let's begin with language overview. So this is, as a programmer, this part is what you want to go through. If your goal is to master mathematics, master Wolfram language. First of all, you play with it. You look at all the fancy functions, which is vast majority of Wolfram language users do. They are scientists. They are not really, usually they are not programmers. They just want to, they have lots of data. They just want to visualize it or do computations. So you try a function, and there are a lot of examples. You just try it, and usually so that's first thing, you look around. Then, but if you really want to master Mathematica, you plan to really know it well, as a programmer, this part is what you want to know. You want to dive in depth. You want to understand basically each and every of these functions in this core language structure. Okay, basically the first one. Okay, that's what you want to go through. So that's one thing for programmers if you want to really master Mathematica. Now, if you Now again, now if you are a programmer but you don't really, you are a beginner programmer, okay, what do you do to get the introduction? Okay, so what you do is you follow this tutorial written by Wolfram himself. Okay, let me show you where. Fast introduction to Wolfram language. No, that's not what I want. That's not. Let's see. List rule and patterns. Okay, let's try that. I'm trying to find you the book. Okay, the easiest way is just search for Stefan Wolfram tutorial. Okay. Oh yeah, that's the one. Wait. No, that's not the one. Okay, here. Okay, an elementary introduction to Wolfram language. Okay, the page you are looking at, the fast introduction for programmers. I'm not sure I'm not sure it's very good. No, is it very bad? I don't know. But actually, what I recommend is this one, an elementary introduction to Wolfram language. And in fact, he sent me a copy like 5 years ago when he wrote this. So, and I recommend this book. Okay, you just go through chapter 1, 2, 3. If you are a programmer, you can go through very fast. 5 minutes for each chapter or 3 minutes. Go through this one. Okay, Stefan Wolfram, an elementary introduction to the Wolfram language. So, in summary, to learn Mathematica, there are a few ways. One is that you just explore, like play with it as a fantastic giant graphing calculator. You just play with it. Just click on what area you are interested in, just try it. That's one way. So first of all, you do that. You get a feel of what's a notebook and so on. Then the second way is to study this book, Wolfram Language, an elementary introduction by Wolfram. Then another way. Then after that, if you really want to master Mathematica, study this part. Okay, core language structure. Now this is the part that basically haven't changed for 30 years. They added a few. They added like 10 or 20 new conditional constructs. But basically it's the same Mathematica I know of. Anyway, I don't have time to explain it today. I have to go actually. So, any questions? Any questions and comments? Okay, 5 more minutes. I'm going to close. So because I have to go. So because otherwise I'm going to actually teach you the fundamentals of Mathematica as for programmers. Okay. Because I've been coding it for 10 years. I also work at Wufang for a while in 1995. So the language is essentially, the nature, the construct, how do you program, it's essentially the same. They just added 3,000 more AI functions. Like one function, some of these functions, like for example, we showed the dist contour plot. How many lines of that is in Haskell? 10,000. Okay. Yeah, that's true. How many lines to write this in Haskell? 10,000. Yeah, not enough. 20,000. Okay, just for this function, you have to write 20,000 lines of Haskell. Now, if that's not even including graphics functions. I mean, Haskell doesn't, most languages doesn't have built-in graphical API. They cannot show a graph like that. If you count the graphic stuff, that's like 10 million, 1 million lines of code right away. But let's not count that. Let's just say to be able to find the points that's the same, a bunch of points that forms a mesh. to do that in Haskell, yeah, 20,000 or maybe 10,000 lines of code in Haskell, and in C it's 100,000 lines of code. So that's why, yeah, and Mathematica has fixed, that's why each function in Mathematica is kind of very condensed. That lets you do prototype or some idea about sound, about visualization, about getting information from statistics or artificial intelligence research, prototype, machine learning. That's why it's incredible. Okay, incredible. Let's look at some of the questions. Post questions. Okay, I'm gonna shut down. Have you ever used Wolfram Mathematica in industry for just or just for fun? Well, of course, Wolfram language, they are in a different industry than programming. Okay, I gotta go. In most programming languages, Python. I gotta go. My alarm clock went off. Let me talk for 5 minutes. Okay, so in most like Golang, C, C++, what's their industry? Well, C, for example, writing operating systems, embedded devices, Linux kernel or drivers, mouse driver, you need C, or C-like languages. Rust, for example. What about C++? Well, some of them you can do with C++, but usually not. Then C++ is often used for, gaming. Gaming, you write 3D game engines, right? And Golang is kind of similar, okay? And Rust, kind of also fits that bill. Now, for Python, Ruby, Bash, what's their industry? Usually, web programming is usually higher level web programming, prototyping, or artificial or interface to artificial intelligence. For example, Google has quite a few neural networks or machine learning libraries. They are usually written in C or Java, but the interface to them is usually Python. So Python, Ruby, or Bash, Python, Ruby they are good. They are higher level. They are, you can write a web application. You can write interface with them. That's basically their industry. You don't write an operating system with Python. Okay, almost never. Then so in a similar way, Mathematica has it. So where is Mathematica used? It's not right. You don't use Mathematica to write operating system. It's not low level. You don't use it to write a game engine. You don't use to write. So what do you use it for? It's usually not used by programmers. It's used by, well, today a lot of programmers. Let me explain. Okay, but mostly it's used by mathematicians, physicists, engineers in diverse fields, in geology, biology, biochemistry, in chemistry, in physics. You do research, you have lots of data from NASA, space, stars, telescope data. You want to analyze the data. That's what Mathematica is for. Or if you are an engineer, you are building a car, you are designing a new engine, you want to prototype, or you want to have a heat, if suppose you are building the engine for a jet, jet fighter, huge, how do you call those engines, turbines, you want to model, or you want to model whether, science and engineering, that's the scientists and engineers, that's the people. That's where Wolfram language is used in. Typically not programmers, but beginning around year 2010, lots of programmers as well. Because why? Because machine learning, artificial intelligence, neural networks. Google is very big with it. You need programmers started to, for example, today there are quite a few jobs of data science. Where you don't just you are not you have to be a mathematician, statistician, but you also have to code. Coding is actually part of your main job. You have to code a lot. So that's where Mathematica is used these days by programmers as well, high-level programmers, not the typical C, Rust, those type of people, guys. who talk about memory and int and float all the time. Okay, that's it for today. I gotta go. So thank you guys for watching. Buy my tutorials or donate, Patreon me if you like my stuff. And again, you can, I got Wolfram Language for free. You can get, well, because they send it to me. Okay, so, and but you can also get it for free. Very cheap or free. So I have a link. I talked about it in the beginning of my video. Where's my link? I don't have the link. But anyway, so thank you guys for watching. Bye, guys. Okay, I'm shutting down in 1 minute. Any more questions? So yeah, in 1990s, I do visualization kind of. If you want to say, the question is, have I ever used it for industry? Yeah, I wrote lots of programs. For example, I showed in my last video all these programs. Basically, you can say they are in educational industry. Let me show you my first most popular project. Visual Dictionary of Plane Curves. So this is math education industry. You can say that. So I wrote all this. This is 1997. I wrote all this in Wolfram Language. They tell you lots of the properties of curves. They especially visually, so you can easily understand. For example, this curve, there are quite a few spirals. This one is Archimedes spiral. This one is equiangular spiral. This one is called littus. Littus is interesting because you can see. Let me magnify. Okay, so you can see it's used in. It's a model of the Pope's Archbishop Corsair. This thing is called Corsair, so it has history, and it's also the violin squirrel are modeled after this curve. So if you are building a violin, if you are a carpenter building a violin, how do you create this thing? Well, mathematics. Okay, this curve is called littus, and there's formula. So I wrote these mathematical programs to kind of for math education. When you are studying calculus, so you can easily see. Once you see this, you understand it right away. Lots of properties. So there are different spirals. How they differ? For example, this one you also see very popular. You see it all the time, like especially all the memes. Let me show you some. For example, seashells or this cauliflower. This fractal cauliflower. This actually you can buy. And the growth of seashells. Okay, so. And this page, the mathematics of seashell. This is again plotted with Mathematica back in 1995. Okay, so I wrote this. So what's special about this spiral? Why is it like? What do you mean equiangular? This one is called equiangular spiral, also known as logarithmic spiral. A bit history and description. Why is it equiangular? Because if you draw a line from the center, called the center or pole of the spiral, you draw a line, okay? Then the line will always cross the curve in a degree, in an angle that's constant. Doesn't matter where the line is; it will be constant everywhere. So this curve is actually, there's a family of them. All these, any one of these are all equiangular spiral. So they just have different constant, the angle is different for each one of them. So you draw a line, for any one of them, there will be the same angle for any line. So that's why it's called equiangular. And there's lots of properties and famous stories. One of the mathematician, who is his name? History. Who died? When he died, he says, when I die, on my grave, I want a tombstone that says, "I shall rise the same, though changed." Okay, that is, in Latin. I don't know how do Jacob Bernoulli, one of the famous mathematicians in 1600s. So I don't think you can actually see the tombstone, or can you actually, on Wikipedia you will see it. Yeah, there's a tombstone, but yeah. So here is Jacob Bernoulli's tombstone. You can see a equiangular. Back then, so all these properties, how do you know? Well, in the 1500, mathematicians studied it. It doesn't come free. Today it's very easy to explain and so on, but before you don't know. So anyway, so that's one of my projects. So technically, it would be in educational math education industry, and Archimedes spiral is also very interesting. It's a spiral such that the growth, the length of this, how do you say the turning rate of the spiral is the same as the arc length, the constant ratio, something like that. I did this 25 years ago. Uh, so this is called Archimedean. Why is it Archimedean? Because Archimedes, the Greek mathematician, like 2,000 years ago, he knew this. He knew this, and he actually created a device to get the water up something. You can. So there's today there's a Wikipedia article on any of these curves. So they have a lot of photos and history, much more than what I have today. So I did this in 1995. So that's it for today. Okay. uh okay, I gotta go. Thank you guys. Bye. Where's the chat end stream?